Today we're preparing to build an 1100 watt pure sine wave solar generator. And we've assembled our components here. I've got a DeWalt toolbox. I've got a trickle charger to maintain the battery when it's not connected to the solar cells. We've got a Renogy controller, 1100 watt, 2200 watt surge inverter, and a Renogy deep cycle lithium ion phosphate 12 volt 100 amp battery. This is the mini core model. And we've got sundry products like fuse block, fan, vents, electrical outlet and waterproof cover, fuses, assorted wires and cables, and an AC port plug, on-off switch, and a small voltmeter. So the first thing we're going to do is we're going to lay out our equipment to find out the best placement. These lithium iron phosphate batteries are designed in such a way that they can be laid down on their side. Now, the battery does fit vertically. However, I know with the other components that need to go in here, I'm going to have to install a shelf along here that opens as I've done in previous projects. So we're going to plan on laying this down on its side. So now we have 120 volt GFCI outlet box mounted. See from the inside. And I've got the fuse block mounted. And beneath that, I've got a pigtail for the, you don't necessarily need to mount these with a permanent trickle charger. If you prefer to just use a trickle charger and use the alligator clamps whenever you want to, charge your battery. But I prefer to have it hardwired in. The AC plug that will be used to connect to our trickle charger to maintain the battery. Okay, jumping ahead to the final product. We have an exhaust fan on the right side with an on-off switch that's wired directly into the fuse block. There's a pilot light on the top. Not necessary, but handy because it shows us when the battery power is turned on. On the front is a USB port, a few ports there, and there's a meter here, DC meter, voltmeter, that we can see through the lid when the battery is turned on. And of course, this is our battery power on-off switch. Also on the front is a Renogy BT1 unit. This transmits the status of the unit when it's running to my telephone, my iPhone, so I can monitor it remotely. And then inside, you can see my mounts. This particular area, we've got our controller and we've got our trickle charger. These boards will pop out, these couple of screws, in case I need to access the wiring, the big fuse block, and so on. And over on this side, we've got our power inverter. Same situation. It's mounted slightly above the battery so that the airflow from the fan and the side back vents, there's good circulation. I get air moving through the whole box. Okay. So that's the inside. It's a little tight. It's a little inconvenient to have to take two screws out to get under here, but at the same time, it's something you rarely have to do. And in a small confined space like this, you've got to make some sacrifices. On the left side, I used these wire ports with my two cables that'll tie directly into the solar panels. And I put a few stickers on this, a few labels, because, you know, somebody else may be using it and they're not familiar with procedures. Note that coming out of the rear of the unit, I have a black wire with a brass end that connects to the ground screw on the inverter. This is so that you can use alligator clips and connect it to a ground wire. This is important because in order for your fault interrupter outlets to work properly, you have to have a ground. So it's additional safety. This is the ground wire I set up. I also keep startup and shutdown instructions in an enclosed plastic sleeve that I'll keep inside the unit, along with a schematic. For anyone else who may be using the unit, maybe another family member who's not that familiar with it, the important startup and shutdown is really critical. Also keep the component manuals along with a solar panel disconnect tool and a remote on off for our inverter. I can turn this on. You see our pilot lights on. And then I can turn on our inverter. See, we're reading 13.2 volts. The inverter showing 13.1. Control at 13.2. So we're good to go. I hope you enjoy your build. Be safe, take your time, and I'm sure you'll be happy with the end product. Have a good one.